What's up, guys? This is Matthew Burns. I've never used this OBS software or whatever before. I figure I'm going to get into live streaming. It's a little bit of a demonstration of capability and just to put the fun things I do up on the web since I'm doing this kind of stuff all the time anyways. Let me lower my mic volume a little bit. I think it's looking a little bit loud. Testing, 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 testing. Alright, that seems pretty good. So, what we're going to be doing today is we're going to be designing two switching converters, and rather than talking about it, I'm probably going to hardly talk. But the plan is to do a buck and a forward, and we're going to route it a couple of different ways. That way when we get these in and test them, we'll be able to see what the best sort of layout was with regard to minimizing the switching noise showing up in whatever it is we're doing downstream. Alright, so right now I'm just interested in finding a buck converter to design around. And I really don't care much as long as it's reasonable. Like, I don't know, probably do like 12 volts and give myself like a nice happy 5 and a 3.3 or something like that. That seems reasonable. One or two, 1, 2. Don't much care about this, but let's pick something reasonable. Like, let's say an FPGA will draw somewhere between like 200 and 500 milliamps. Whatever, let's say something like that for core, something like that for auxiliary, and just like a little bit for the VCCIO. So let's say like 500, 600 milliamps total, or something like that. So let's find something that'll do 1.5 amps on each channel, since we're looking to do a 3.3 and a 5. Probably didn't need to include that much. Alright, input minimum. So I want to put 12 volts into this thing. I'm going to put some margin on that and say like 18 volts and up. Should probably be a little more careful, but this is just for a test. Maximum voltage output max, that's not very good. Voltage input max. 36 and up sounds good. Voltage output minimum or fixed. So let's select all of them that have like 3.3s and 5s. Or better yet, let's not select any of those. Can I select two outputs at this point? No, I don't know if I can. And it looks like I over-constrained myself. Let's get rid of this. Let's get rid of this. Hey, I'm starting to see my favorite ones up here. Okay, what doesn't matter? What's fine? Surface mount, active, in stock, exclude. Voltage input minimum. That doesn't seem quite right, especially since I want to do 12 volts on this. So analog devices, let's just say that because that's nice. Happy land, output configuration, everything that's positive. Voltage input minimum. I think everything up to 12 volts. Maybe that's what I did. Wasn't thinking clearly. Voltage input maximum. Let's do like 18 volts and up. Did I do that? Did I not? That's okay. Except not those. That's okay. Probably not going to get a part that's fixed. So output min, we'll do everything up to 3.3. Well, whatever. That'll show us mostly what we're looking for. I don't really care about that. Current at the output, what did I say? We'll do like, I want to put some margin on it too, so we're going to do like 1.5 amps and up. I don't want this thing to cook if I were to use this for an FPGA type application. That doesn't matter. Of course they are. And let's see, most of them that are in stock. $3680 is an adjustable buck with one output. 8582 has two outputs. And it can take 12 volts in. Clearly it's not just a buck converter. It's some other switching topologies. I just want something nice and simple. And you know what? I think I only want to deal with one rail. Wait, well, most of the applications I'd be using this for, we're going to have two, but this is a simple test. We're going to do it quickly. And we're only going to choose buck converters for the first part of this, and then we'll choose a forward for the second. $3680 step down buck adjustable, 3.6, so that'll work. Looks good. 3.5 amps is more than we need anyways. 2.5-ish megahertz, and that's pretty small, but I think I could solder that, so that shouldn't be a problem. .5 amp 10 DFN. 3.636. So it's basically, is that the same thing basically? The 3693. Oh, not quite. Similar. Okay, yeah, we're just gonna go with the 3x3, 3.5 amp, 3680. The other thing is, does this have a SnapEDA model? Okay, so if it's not in KiCad, no problem. So I'm going to go through the whole schematic and everything, but I don't have a whole clean setup yet for this. So when I create folders and stuff like that, I'm going to move my work off screen. New project, documents, personal projects. And this one is going to be buck converter layout test. And we'll call this buck. Yeah, that's it, buck. Save. Alright, we'll create a schematic. And first, I'm going to see if this part is in the KiCad library. Oh, save me some trouble. Otherwise, I'll just get it from SnappyDA real quick. Well, while that loads up, I'm going to get some water. Okay, yeah, it looks loaded up. What part are we looking for? 3680. It would be smart of me just to use a part already in KiCad library, except actually, in my experience, then it's not even going to be on DigiKey, it'll be out of stock. So we are going to download all of this. Alright, I will get that from downloads off screen. Extract. And we're going to rename it to the manufacturer part number. I need the KiCad pretty folder. The KiCad mod file goes in. And in case y'all are interested in what to do with the step symbol and whatever, if you're downloading footprints, I might see if I can do some of this on screen. Let's see if I go to personal projects, buck converter layout. Alright, let's do that. That should be okay. Okay, now you can see my folder. I've copied the 3 files of interest. What I'm going to do is, this is the KiCad directory here. Click on buck. This you could do however you like. It doesn't really matter. I like to create a folder called libraries, and just, oh, well, that's one way of doing it, not what I intended. New folder, footprint. You don't need to do this either. Step, and symbol. And this goes in footprint, this goes in symbol, and this goes in step. Now, let's pull up this, preferences, symbol libraries. In case this pulls up my directory structure, it did. Let me do this off screen. Libraries, symbol. So now I'm just opening up the KiCad symbol and hitting OK. And I'm going to do the same thing for footprint libraries, except off screen again. It's going to get annoying. I got to figure out a better way to do this. Libraries, footprint, open. Okay, I definitely got to figure out a better way to do that. So now we should be able to pull that symbol into here, except it's probably going to look ugly. May not matter at all if you're trying to do this quickly. I always change the symbol slightly to make the schematic easier to read, but you should be able to at least find it now. Yeah, and it looks pretty terrible, but that's fine. So, at least to make it moderately readable, I'm going to edit the symbol. And it is the LT3680. There it is. First thing, I'm going to get all this crap that nobody ever uses out of here, because what the hell even is... Oh, sorry. Shouldn't say that on stream. What even is that? Next. This is just me being picky. Rubbish things that don't matter. Alright, just to make this look like a reasonable switching converter, I'm going to put power in the upper left. I'm going to put, where's my enable? Run, soft start. I'll put that underneath it. That may have under voltage lockout features, I'm not sure. Or I may just put a capacitor on it for soft start. Switch, it's going to go over here on the right. Don't know what E-pad ties to, so let's figure that out. It'll help determine where we put it. Is it ground? I've seen one weird Texas Instrument switching converter that I used earlier today, actually. I used to generate split rails, plus and minus 8 volts, and the ground pad went to -8, so that was pretty weird. I mean, I guess it makes sense, but exposed pad must be well, duh, must ground. There we go. Okay. So what I'm going to do is I'm going to take ground. Is that the only ground on this chip? My quick link to pull up the things on the other side. Is E-pad the only ground? Yeah, it looks like it. I was gonna say I would make it invisible and over the ground, but it looks like it is the only ground. So we're gonna rename it. Sync. We are not gonna drive this with anything. Maybe I'll bring it out to a header. I can use it for some tests later. Power good. We are not going to use this for anything, but 100K pull up to the input should be good. Or to the output. Still going to put it over here, though. Feedback. We'll put that right here. Where's boost? Boost we're going to put right over here. Timing resistor is going to go down here. VC. It's compensation network junk. We're going to put that right there. Switch is going to go here. Alright, what grid do we have? Too small. 1, 2. I'll put that there. Two, 4, 6, 8. That looks good to me. Oh, there's a lot of stuff on this side, huh? VN. What is BD? I'm gonna have to figure out what some of those are. Run soft start's pretty much gonna go right there. Whatever the heck this one is, I gotta figure out. Timing resistor can go right here. Power good. I'm just gonna like tie that to a local net on that page and pull it up somewhere else. Sync. Somewhere around there. Depends on whether I use that as soft start or an under voltage lockout. I gotta read the data sheet for that and whatever this is. So let's pull up the data sheet. Go to like the only part that I care about. This pin connects to the anode of the boost Schottky diode. Also supplies current to the internal regulator. There's the typical application circuit. Okay. Well, the typical application circuit doesn't lie, I guess. But that's a little different than some other switching converters I've seen. No problem. So, what am I going to do? I'm going to move this over here. BD is going to go above boost. Move these down too. Oh. And sync is probably like, I don't know, they're probably going to say tie it to ground for a certain mode. And I'm going to be like, okay, so whatever. This looks good enough. Yeah, the typical application ties sync to ground. I'll read the data sheet. Power good is open drain. This is just resistor to ground, compensation network junk, which we may or may not play with. And let's figure out run soft start. Okay, run soft start. Is used to put it into shutdown mode, tie to ground, tie to 2.5 volts or more for normal operation. So I'm going to see if I can use that 2.5 volt as like as legit for like UVLO. Is it like repeatedly 2.5 volts? Can I put a resistor rider on it if the shutdown feature is not used? Tie the pin to VIN. Also provides soft start. It's the application information section. Voltage controlled ramp. I mean, that looks like me just putting a cap on the top resistor of the feedback, which I'm probably going to do. It's also clamped to the voltage. Okay, by choosing a large RC time constant, the peak startup current can be reduced to the current that's required to regulate. The peak startup current can be reduced to the current that is required to regulate the output voltage with no overshoot. Choose the value of the resistor so that it can supply 20 microamps when the run soft start pin reaches 2.5 volts. What are they referencing when they say that? Or am I looking there? Run soft start pin can be used to soft start the 3680, reducing the maximum input current during startup. Run soft start pin is driven through an external RC filter to create a voltage ramp at this pin. Figure 7 shows the startup and shutdown waveforms with soft start circuit. Okay, I see. By choosing a large RC time constant, peak current can be reduced so that the current that is required to regulate the out can be reduced. The peak startup current can be reduced to the current that is required to regulate the output with no overshoot. Choose the value of the resistor so that it can supply 20 microamps when the run soft start pin reaches. So basically it can't be more than the resistance that would chew up the difference between the input voltage and 2.5 when 20 microamps is being pulled through it. So that's easy. Okay, whatever. Synchronization. To select low ripple burst mode, tie sync below 0.3. It can be tied to ground. So low ripple burst mode will be when the thing's tied to ground. Synchronizing the 3680 can be done externally by connecting a square wave. Will not enter burst mode at low output loads, but will instead skip pulses to maintain regulation. What if I want to keep it switching, like good old continuous conduction mode? Like, is there a way I can do that? Maybe synchronized over 250 kilohertz to 2 megahertz range, a timing resistor, blah 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 blah. Okay, I guess not. Whatever. We're gonna tie sync to ground. Okay, that's a pretty good idea of what most of these things do. So I'm going to make it look a little more reasonable, and then we'll get to it. Something like that. There's nothing on top. Whoa, don't know what happened there. Get all this junk here. That's close enough to the center, right? Good enough. Looks good to me. So now we're going to get rid of this. And put down the same part. It looks a lot better. Maybe it's too small for a switching converter, but once we put everything else in, it'll be nice and happy. Timing resistor. So I don't know. Why don't we run this thing at 2 megahertz since it can? And keep our inductors nice and small. I mean, I imagine it'll be easier to have noise problems at who knows. I'm going to run this thing at synchronizable between... Okay, it can run up to 2.4 megahertz. In case I want to try doing some synchronization stuff later. Let's do 1.5 megahertz. So there should be a frequency versus RT chart on here. Switch. Something like that. Blah, blah, blah. Or maybe it'll just tell me. Resistor to ground to set the switching frequency. Yeah. Switching frequency. Okay. So it looks like this data sheet. I can move this over. Just gives a chart here. Let's say we're going to pick 1.6 megahertz. That's 18.2K. Eight. 1, 2, 3, 4. 8. Okay, compensation network stuff. We're not going to get too wild. We're going to pretty much stick with the typical application circuit and put in some or an extra capacitor pad, just cuz. So we're going to leave this as a do not populate. I want to do a good layout. So it's okay. We'll do 042. It's nice and small anyways. That's a do not populate. This, we're going to start with the typical application circuit. We'll check later. Checking later, my favorite. Rarely ever get around to it. Okay. That's okay, good enough. Sync. We tie sync to ground, right? So, like, actually, it might be worth moving that down here. Just to, like, keep everything looking clean and readable. And I'm not going to get too fancy with this. Maybe I'm just going to put like a DNP pad on here for soft start. And I'll put some soft start on it, basically. I'll play around with it later. I'm not going to bother with any unvoltage lockout or anything like that. I just want to keep it simple. Looks good. And maybe I'm just going to update symbol. Cool. Move these over. This is too far. Okay. Well, let's start wiring it up. That was the easy part. I always like to start with that. Okay, power good. Like, I'm not going to do anything with this yet. Alright, run, soft start. In figure 7, they have their example there, and I'm just going to start with their example and make sure it'll work when I finish this whole thing. In other words, I probably won't. Actually, I will. Let's see. Value 15. It's not tasteful. That's also not tasteful. That's okay, I'll suffer. So now the input. I am not afraid of putting an electrolytic on this board. So that's exactly what I'm going to do. And it's going to be, what, like I don't know, 68 microfarad. And then I'll have 3 ceramics, 2 like 1206s, and I don't know, 603 probably, or something like that. 2 10Ks, and 2 10 microfarads and a 0.1. Come on, what's the deal? Okay, this is very weird. My KiCad won't let me move my mouse outside of the bounds of this box. I have not experienced that too often. Control S, Control Alt Delete. Nope, not what I wanted. No, don't do that. All streams are recording and will be shut down. Are you sure you want to exit? That is not what I want. Control Alt T is what I want. X kill. Alright, see you later. Seem to fix the problem. We can get rid of this. And no, I don't want to exit my stream in the middle of it. KiCad. Let's see. File, close project, file, open project, documents, personal projects, layout, buck converter layout test. Okay. Yeah, okay, whatever. I'd appreciate it if you didn't lose anything. Alright. Says it lost a bunch of files, but it lied. It's my favorite. I don't know what that's about. Some rubbish. Oh, that's not how I want this anyways. One of these guys, just so that any line impedance of whatever supply I'm plugging into this thing doesn't cause a voltage spike when I plug this thing in. I'm gonna do that. 0.5 ohms. Oh, not what I want. Okay, we're getting there. 12 volt. Sounds good. Did I make sure this part? Yeah, I did. I selected the part appropriately for that. Okay. Now the boost capacitor. C small. Value 0.1 microfarad probably. Let's check the data sheet. See what they recommend. Again, typical application circuit. .47 microfarad, a little bigger. I'm not going to fight with the data sheet. And 4.7 is our favorite number because that's our inductor too. I'm also not going to fight with the data sheet on this one. Also, at 1.5 megahertz, that seems very suitable. I doubt there's going to be problems. L small. Value, nope. Value 4.7 microhenry. Yeah, looks good. Okay. Now I need the feedback resistors. And I want to get a 5 volt out of this. Because then, like, I don't know, even though core voltages and whatever are 1.2, 1.8, or whatever, I'll probably turn this into a 3.3 that get used for lots of I/O voltages, maybe auxiliary voltage. So that means, since the datasheet gives me a typical application circuit for a 5-volt step down, the feedback resistors are good for a 5-volt output. Except they probably pick some values I'm never going to find unless I use some obscure manufacturer. 536K, maybe. I don't know. It almost sounds okay. Is that tasteful? Need some output capacitance. Ooh, I don't like the way that looks. I'm being picky. Alright, output capacitor time. And this is my nice happy only ceramics land. I use 47 microfarad. I'm going to use 222 microfarad and a 0.1 microfarad. I always like to do a few. I don't want to run into a problem where I need the thing to handle I know I've heard some people say they could bring against each other or whatever. I've never had problems with that. I don't want to run into a problem where my output capacitance can't handle the ripple current that's required by the switching converter based on my inductor size and all kinds of other stuff. So having a couple is never a bad idea. And 5 volts. Looks good to me. Alright, the circuit's almost a-okay. Except I am just going to get rid of that local net thing, and I'm going to be completely terrible and do that. It also doesn't look very good to me that I have 2 different levels of grounds on this. It's just me being picky. I need to make something moderately readable. Okay, how are we looking? We need a power connector. Don't really need bulk capacitance at that power connector because this is literally the only thing on the board. Am I going to put a micro on this? No, I'm not. I'm going to keep it simple. We're just going to put this on the board, and we're going to use some kind of meter or scope or whatever to figure out what noise we can see at the output of this thing. I am not going to put any sort of ADC device on this. So we've got power going into this thing. We've got it grounded, so it's 90% of it. It should work, right? Feedback resistors look good. Output capacitance, boost capacitor, this funny business. Compensation network stuff with do not populate. We've got some soft start on this. 20 microamps. What's 12 minus 2.5? I said I would check this later, so let's check this. I bet it's fine. 12 minus 2.5 divided by 15,000. That looks less than let me read the data sheet real quick before I look stupid on a live stream. That's probably what this is all about anyways. Choose the value of the resistor so that it can supply 20 microamps. Microamps. Yeah, and that's 633 microamps. Yeah, I was looking real stupid. Yeah, this is perfectly fine. Okay, looks good to me. Other thing is, this is only going to change the RC time constant of the soft start. I might make that a 0.47, whatever. Like, buying an extra capacitor is not a big deal. So yeah, let's get an input connector on this. And I am going to be terrible. I'm going to use, like, I'm going to see if I can find some part that's like a board mount banana jack. Something real weird. Let's add one of these to cart now. Even though I'll probably just get it from Mauser tomorrow. Or not. Sometimes the libraries also don't have the part number exactly the same here, which is moderately annoying. That looks good. Okay, we're going to get the banana jack. Okay. And we're going to get like a solder in version. Hey, like this might be more or less what we're looking for. In stock. Exclude. It'd be nice if it had an EA-CAD model. Active. EDA-CAD model. Okay, I don't care about the color. Actually, no, you know what? Like, I'm dumb, and I'm probably going to plug the red one into black and the black one into red. The silk screen's going to save me, so I don't care. While this loads, I'm going to get some water. Okay. Is that what I think it is? Am I like making up parts now? Is this gonna like just sit in a through hole and let me plug a banana jack right into a board? Because that'd be nice. Do I solder this in place? Standard. It looks like I make a through hole. I'm gonna make a through hole. I'm gonna solder this right into the board. I think that's what this is. Excuse me. Oh, like maybe I'm just gonna have to make a test point. Like, whatever. It's good. I don't know whether I accidentally tied that to this net by naming it like that, but we'll find out when I start routing, huh? I've run into one problem like that pretty recently. That wasn't very good. But live and learn. Let's see. And I am not dealing with input capacitance on this, like bulk capacitance, because this is going to be right next to this. Like, I get credit for that. Lastly, do I want to put a TVS diode on here? Like, yeah. TVS, is there a small filled for TVS? Nope. That's okay. I'm not going to be picky. I'll label it mystery. Looks good. Okay, now what? I'm going to want to put test points on the output of this so that I could hook up an electronic load or a big resistor or something dumb. So I'll do that, and I'm also going to want to put some scope probe test points. Mirror horizontally. Let's like have it at the same height, because I'm going to be picky. Wait, I'm totally going to put a micro on this. And I'm going to put an ADC on it. I'll throw something together real fast. Like, I'll put an ESP32 on it. And I'll sample a signal that I bring from off-board. First, let's handle this. I'll deal with all that in a minute. I want it to be as dumb simple as possible. So like ESP32 room or whatever you call them. Put one of those things on there. That's a really bad looking connector. Whatever. Not a problem. It's not good. I want it to be good. Like that. Is that moderately okay? Like, okay, I gotta get into the working mindset, not the goofing around on YouTube mindset. That looks good. I'm gonna make this thing somewhat hierarchical, only because I'm gonna put just a few things on this. Power, power, and yes, the power connector is going in the power page. Deal with it. It's okay. Right here, 2 over, just above B. That point. Hey, perfect. I'm not going to bother putting another sheet on here. The ESP32 will be run off a 3.3 that I'm going to run from this. So let's pick a linear regulator real quick. Yeah, let's pick a linear regulator real quick. Let's also label the test points with these, or not the test points. The banana jacks. I should do this, shouldn't I? Horizontal line left. Okay. I could sort of line these up if I shouldn't be wasting time on this. But it takes 3 seconds to make it good. There. Now let's get test points, and we're going to find some like scope probe stuff to solder in so we could easily hook up a scope, just because why not put a little bit of effort into making this halfway easy to use. Probably put like a separate one for 5 volt and ground, and yeah, I'll put a separate one in for 5 volt and ground. And I'm going to just copy this, except put it all the way over here. And it's not going to be banana jacks this time. And we'll deal with this in a moment. That looks reasonable. And let's find some test points to use. Standard hook. Standard. I like standard. Is that going to be as easy as I think it is? Pretty much anything with like a little loop looks like it'd be pretty easy to This is what I'm looking for. Something like this. Alright, do we have one that like would be good for ground? And one that would be good for power? Like, that seems good to me. Do they have a prox Keystone Electronics? Do they have like the same footprints? Whatever, we'll deal with that later. One thing at a time. So 5011 and 5005. All good? Now it's all good. Okay, now that that's dealt with, power good. Looks like pulling it up to 5 volts. Oh, wait, this is not good. That was very bad of me, and would have caused problems. Yeah, that wasn't very good at all. That was pretty goofy. 100K should be good. Now we'll put this here. Ta-da! Almost messed that one up, huh? That looks good. That looks good. I can move that a little farther, and I can give myself some more space here. You know what? Like, deal with it. It's okay. I can even move this further. That way I can label the net. That way I can run it to the linear regulator that I'm going to put on here. Once we pick one. Because that's our next step. Wow, that was a close one. That was stupid too. Alright. Linear regulator. Oh boy. Didn't realize. I thought I'd be able to get this thing done in just like, oh no problem, an hour, like 5 hours later, and this whole thing will be done. That's okay. We're going to route this a couple of different ways, and most of the routing is going to be the same. Then I'm just going to copy and paste the board file, name it different things, and then change them slightly. We'll do another live stream when I get the boards back. And we're going to use a fixed regulator with one output, just positive. And it's going to be a 3.3 volt regulator. Oh, come on. You're good to go. Ugh. I've only been doing this for an hour. That's not horrible. Output min fixed. 3.3. And can I just leave it there? That would be simple. Yes. Now say I want to pull an amp from this. I'm going to get like some big, beefy linear regulator, like a D-Pack package. And I certainly won't, if I want to pull an amp from it, I'm going to have to like say I want to pull 2 amps from it. I mean, otherwise it's going to cook itself. We could do thermal stuff later, but I'm just going to eyeball it. And I want a surface mount. And we have a power good. We might as well use it for enable. We don't need that. But they could have features, and we could just not use them. It's okay. And I'm not talking to myself, for sure. There's definitely somebody else that I'm talking to right now. Lol. Oh, chat is disabled for this live stream. Dang, I might have like 1,000 people watching this right now. Be just like my, be just like my, serial peripheral interface to a SD card video. None of these are really what I was looking for. Probably put the current too high. I'm probably asking too much. And voltage input, I wouldn't go like anything under 10. Not going to worry about the power supply rejection. What? Oh, current output. 5 down to 800 milliamps. Give ourselves a little more room. Let's see what we come up with. Like, any of these will be fine. Whatever. Let's see what has a lot of them available. I want a D-pack package with like a solid pad that gets soldered to ground. Oh, did it do the thing? Oh, I guess my wish might not be granted. But I don't want to make my life hard soldering-wise. Maybe that's all I'm going to get there. Okay, I should... There's a lot of these in stock. And like, this says it'll do 1.5 amps. I could look at its thermal resistance and whatever later. I'm just going to use this part. 3.3 volt. So it's not particularly high PSR. Doesn't specify what it would be out of megahertz or 10 or whatever. But whatever. Next thing is, does LT Spice have a Snap EDA does? Oh, that's not good. Ultra Librarian, you gonna save us? It's gonna say no exact part was found, but this is close. No, that looks good. I'll take it. I mean, those aren't particularly large pads, but I'll take it. That is A-okay. First, does KiCad have the symbol LT 1963? Yeah, it does. Good. 1963A something 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 dash 3.3. This shows it is a 5-pin part, but that's not quite right. AEST-3.3. So this is the part here. It is a 3-pin part, and the pad is tied to something. So we're gonna like do that. Make some space for it. See, the thing is, the whole purpose of this live stream was to determine the best way to route a switching converter. But if I don't put something on there to, like, you know, approximately see what my, I don't know, RMS noise on some ADC channel is, then, like, what good is it? Oh, more caps, more caps. Can never have too many of those. So if I put like an ESP32 on here, and I, like, maybe I can put like a little web interface on here. And what I'll do is I'll like have a couple of ADC channels. I'll have a couple of ADC channels. Looks good to me. Couldn't get much simpler. Oh, except those capacitance values need to change a bit. A couple of ADC channels, and I'll just, you know, keep an eye on them. And I'll put different loads on this thing in the meantime. Value 0.1 microfarad. value 0.1 microfarad, 3v3, 5. Okay, so far so good. Now what if I also wanted to add test points onto 3v3? I mean, I'm gonna do it, so like let's just do it. Oh, that was obnoxious. 1, 2, 3, 1, 2, 3. Let's get those out of here. You know what? This will be almost the same. We'll give another ground test point too, because why not? Alright, does that look remotely a-okay? Yeah, I have a way to like draw a bunch of power with an electronic load from 5 volt. I have a way to measure the 5 volt line and the 3 volt line with a scope. Do I want to be able to draw power from 3.3? I don't think so. I'm not going to worry about that. I think I'll accomplish what I need with this. Now, I'm going to make life easy by doing the following. I have a project that I will be live streaming with you guys. It's a VNA that I've been working on. I'm going to borrow the ESP32 from the VNA that I've been working on. Let's open up that KiCad project, but I'm going to move it off screen so you can't see my directory structure. Oh, I hope I saved that. Lol. Wait, actually, that's not what I want to do. Open recent, buck.kicad. We'll keep this over here. Make sure everything's all good. Okay, I'm going to want to open up the schematic. That'll be here. In particular, okay, KiCad, VNA. I'm going to want to pull up the ESP32 portion of it. Could not use OpenGL, what the heck? I don't know what it was saying. That was above my head. Okay, yeah, so I drew this up a while ago. Haven't tested it yet. So I guess we'll get to that, huh? Oh boy. I don't want to go to a bigger page, but I also am not liking this. As long as it fits. And this is not going to be going over to the FPGA anymore. Like, at all. ESP32 room. Is that the one that... I forget. That has Wi-Fi built in, doesn't it? Let's delete. Delete. Make sure that has Wi-Fi built in. Yeah, so this is the room. It has the meandered inverted F sitting up top. So I think we're all good. I don't think I need to do with... Were any of those I/O strapping pins or no? No, it looks like all of those were being used for the FPGA configuration SPI and configuration data bus. So they're gonna go. Bye. I am not here to look over this part. We're gonna pretend that's all a-okay. USB, we're gonna use USB-C using USB 2.0. We'll pick TVS diodes for this. 5 volts is gonna come in, it'll see like 3.3-ish. This thing runs off 3.3 volts. ESP32 room runs off 3.3 volts. Oh, the boot pin, boot and reset are the only lines that need to be managed, and those are managed by the handshake signals. And TX goes to RX, and RX goes to TX. That's always the confusing part, because some of them say your TX, my TX. And my TX, I'm saying TX because I want to hook up to your TX. And some of them are like TX goes to RX. So, in the room data sheet, pin 35. Where is it? Pin layout, pin description, pin layout. Pin 35, TXDO. Is that labeled as an input or an output? IO, huh? That's funny. TX, okay, when it is used for UART, is that UART's TX? That's UART's TX. There's no way it's not. I'm not going to be stupid. This guy. This is the, can I even buy one of these anymore? Like chip shortage and all, CP 2012. And what version is this? This is the 32 pin version, probably. I don't know where those extra pins went. I see a 28. Is 28 divisible by 4? I don't think so. Yeah, we'll find out. I doubt I can even get one of these. Oh, before I leave that page. Let's go to power. We're going to put the full part number so I know what to buy here. Interface controllers. Come on. Rest in pieces my sleep tonight. Or rather, don't rest at all in one piece. How do I enable chat? I feel like... Okay, yeah, I totally can buy these things. They're 28 VQFNs. 28 is divisible by 4? That doesn't make sense. Am I being stupid? Yeah, I am. 7. Okay, yeah, looks like we can buy these. No problem. And... oh, I probably don't have the libraries for these parts here. Unless these were KiCad parts. Let's see. Probably need to copy them over if they weren't. Is this a KiCad part? Looks like it to me. I'm going to do away with any of the confusion by doing one of these numbers. Ta-da! That never happened. And let's get a USB 2.0 or USB C plug 2.0 receptacle 2.0. Whoa, that's a lot more stuff, huh? That's okay. Only thing I'm going to worry about is the fact that there are two D plus and minus so that it's interchangeable. And this isn't a host device. It's a well, this was intended to be used. Well, this part would have been a slave connection. I'm not going to shield. I'm not going to shield the USB. Let's move this over. Move ground. down here. I think, from what I read, and correct me if I'm wrong actually, it'd be real good to see something in the comments. I'm pretty sure a lot of host devices will connect their shield to their ground, and I've seen some forums say that USB not host, I don't know what you call it, doesn't shield their ground. Yeah, so I'm gonna just pretend I know exactly what I'm doing, because I totally do, and we'll see how this thing works. Okay, haven't picked TVS diodes for those yet, so that is A-OK. Deal with that later. Now, the ESP32 room. Is that a... It looks like that could be. Room 32. 21 through 19. Goes up to 37. It's kind of unusual pin count, but okay. Antenna zone, keep out. And what, that guy's the one that has the external antenna, onboard antenna, SMD. What's the difference between these models? BLE, Wi-Fi. Okay, just extra letters. Basically, I don't know. It doesn't matter. Yeah, that's basically it. Use the same symbols at least, because the footprints look the same, and I would say the answer is yes. So that also makes life easy. Don't have to deal with libraries. Excuse me. Now, we're going to pull up the part number for the ESP32 room, or pull up, not the part number, the data sheet or whatever, and we're going to find out what pins we can use for analog. And we're going to, like, I don't know, I don't really feel like having me bring some external signal onto the board. I'm not really interested in that right now. Like, I'd kind of just like to resistor divider and maybe like AC couple stuff onto it from the power supply or whatever. Maybe that's a bad deal. That sounds like a quick way to kill my chip if I have voltage spikes. Whatever. Yeah. It is what it is. Which of these can be used for analog? Let's figure that out real quick. I think I'm in the ESP32 room data sheet here. I think analog, not a pin description. ADC1 channel 0. Oh, whoops, I don't want to use that pin. If it's labeled something else, it's kind of scary, huh? Or it just means is don't really want to take on that risk right now. 30, that's not necessary. I think this module has the high frequency crystal inside it. ADC1 channel 6 and 7. Why don't we just like use those two? Those are IO34 and IO35. Can I use those? Yes, I can. So, like, all I'm going to do, 3, 4, 1, 2, 3, 4. Not exactly like I've done this before, but like, whatever. ADC2. Or just so I can actually figure out what I'm doing when I look at the schematic later. ADC1, channel 6. ADC1, channel 7. And what else are we going to do? We're going to, like, set those right in the middle of 3.3 volts. So I'm going to resistor divider them. It's like a medium-ish resistor divider. R small US, because like the squiggly lines. Bump, bump. Okay. Just gonna... Whoa. What happened there? C doesn't work for copy anymore. No space. And I think these things can, like, supposedly do, somehow, like a megasample or 2 megasamples per second or whatever. But, like, all the forums are like, the documentation is unclear, we can't figure out how to do this. So if we can figure out how to do that, that's a bonus, but I'm not going to fret it. Like, I don't think we're going to catch all the switching noise, especially because the switching noise is going to, like, you know, be in frequency bins that we're not even going to be able to sample. And so we're going to have stuff mixed down into our Nyquist zone from higher Nyquist zones, and it's going to be a bunch of noise and a bunch of other noise from other Nyquist zones, and it's going to get confusing. So I'm not going to worry about all that junk. I just want to see, like, relative comparisons, how much the noise floor rises. Like, that's it, with different layouts. I think that'd be about appropriate. So let's, like, put a big capacitor on here that we don't think will bandwidth limit us, but let us AC couple. How about good old reliable? 0.1 microfarad. If that's a problem later, we'll fix it. Okay, the other thing we're going to put on top of this is another resistor. Just so, like, you know, we're just testing relative stuff. Like, maybe it's possible that we squish this noise into below the quantization noise of the ADC and we don't see the noise floor go up or down, but, like, whatever. I think we'll see something. What are we going to pick? Say we have, like, I don't know, probably a worst case scenario have voltage spikes that are like 1 volt peak. That would be a terrible case. That would be really, really bad. So let's make it worse. Let's say 2. Let's say it's 2 volts. And we're AC coupling those on. We really don't want them to go up much more than half a volt. So like 4-to-1 resistor divider. So if I make this like 33K, so that's like a nice value. We're probably not going to see anything if I do that, right? No, I mean, these are pretty big too. I don't want the current draw of the pin to... who cares what this resistor divider is? I'm just doing a relative test. That's good enough. I'm not going to worry about it any further than that. We'll see what we see. And it's going to be real hard for me to determine using this, which is probably going to be way undersampling the spectrum of noise that's put out by this thing largely, it's going to be hard for me to actually determine what a lot of our noise is with this, whether it's mostly differential or what component of it is common mode noise that like shakes everything. It's probably not worth me using the other ADC, but like I already have it set up, I might as well use it. So like I'm also gonna like AC couple ground. I'm going to put on a bypass capacitor to ground, which like I guess should make the you would think would help keep the thing sit steady. Put some capacitance on the line and some low pass filter and all. But if all of ground's shaking up and down, well, like I guess that goes out the window. We'll find out what happens. I could be being real dumb. We'll see. This is classic me overcomplicating this. I intended for this to be like a quick 10-minute thing. It's not that bad. This is still pretty simple. And like, these are going to move up and down too. Whatever. It's okay. Like, we'll figure something out. We're going to see something from this. Last but not least. Do I have a reset button? Do I care about a reset button? Every time I reprogram it, it resets. That's good enough. See, like, absolute monkey brain me would be thinking, okay, this chip's between ground and 3.3 volts. The whole thing's shaking up and down, like, that's A-okay, right? Like, ADC's only going to measure difference in potential on its ADC with respect to its ground node if you're running it in single-ended mode, so differential noise is all that matters, but not monkey brain me knows that common mode noise does end up showing up in the noise floor of stuff that you're sampling. So monkey brain me again thinks if I get rid of this, I would see differential noise between the 3.3 volt and ground node. But I also know, even though monkey brain me is saying I wouldn't, that I would see common mode noise showing up there. Do I even want that junk that I have sitting there on the left? I'm gonna say no, I don't. In fact, what I'm gonna do is this. And it'll be a we'll see what we see type of situation. Then they're literally identical, but whatever. That's fine. A little bit of redundancy is not the worst. Gonna put an LED on this thing. Just so I can make sure it's no. Yes, we are. We absolutely are. We'll put it right here. Making use of all this good space. Oh, whoops. 120. And my favorite LED. LED. Small. Filled. Just kidding. I'll fish up my favorite LED part number later. I use on everything. Everything. I have my favorite LED. I bet these pins can probably sink and source enough current for this. Is it worth checking? Probably is. Like 2 seconds. Source. Alright, I/O, high level source current is 40 milliamps? Did I read that right? DC characteristics, low level input voltage, high level input current, high level source current. Wow. Okay, it's 40 milliamps. So that's like A-okay to drive this LED. I probably don't even have to be too picky. As long as this is blue, it'll be approximately the same forward voltage, approximately the same current. So like a blue LED will go there. Is that everything I want to do with this? We're gonna get the full part number for this ESP32 room. Put it right there. The CP2012 that we're gonna use, are there these guys in stock? Silicon Labs. Come on. Okay, while DigiKey does its thing there. Let's see if this is pretty much it, because this could be basically all we need. I don't want to overcomplicate this. I think that's all. We're going to program it from here. This should automatically deal with resetting it, putting it into boot mode. This should let it show up as a COM port on the computer. Could probably just like program this thing with Arduino. Use like the example sketch that'll turn on and off this LED to make sure it'll work. We'll just like set up the ADC to like, I don't know, stream over a bunch of values or whatever. See if it's working. Should see about half the ADC's full scale. Then we'll capture a whole bunch of samples and see what kind of RMS noise we get. I think that's pretty much it. I'll find out if I'm missing anything as I'm routing this, I'm sure. So, yeah, let's annotate it. I did just copy and paste in an old schematic that I used on the VNA. That's okay. I probably didn't do anything that terrible. Wasn't the Dark Ages. Looks good. It's okay that looks kind of bad. This is quick and dirty. Let's assign footprints. Whatever, fix that later. Alright, I'd like to moderately see what I'm looking at in the schematic, but I also don't like the whole half-page deal, so I'm going to have to just deal with it. We're going to start with capacitor, surface mount, and I'm going to do all these 0402s so I can get like nice, good layouts. And I can solder 0402s quite well, so it's a-okay. Oh, 4.7. Is that one of the, no, that's fine. 0.1 microfarad, 68 microfarad. So this is going to be an electrolytic, 7.7 millimeters tall, 6.3 diameter is like a pretty standard regular good. 10 microfarad, that's these ones. I think 1206s would be a little small for that. 12 volts isn't that high though. You could probably find them in 1206. I don't want to do a 2220. We're going to do 1206. And if I'm stuck, I'm stuck. We'll solder something else down. It's going to be fine. 0.1 microfarad. We'll lower the input voltage. That's what we're going to do. Back to our 0402s. C14. Those, I think we could find in 0603. It's just 5 volt and 3.3 volt. Come on, come on. There we go. All right, 22. Yeah, those are going to be 2220s. That's kind of big, isn't it? That's okay. I should really take these 1206s and make them bigger too. If I find the routing is I can't bring myself to do that. 1206. If I find I can't do it, then we'll figure it out. Okay. Oh, dang, I picked parts for those? Didn't realize I did. SMAJ11CA-13-F. Where is that? It's not visible. How about that? Whoop. Oh, cut that out. Let's get rid of that one. Let's show one of these ones. There we go. That'll do. Okay, I bet that's like... I wonder if that has 3 diodes in a single package. We'll find out. These parts do not look suitable for USB. I mean, like, they're not going to be a problem, but they don't look like the right part for the job. Ugh, didn't want to be searching for diodes right now. Whatever. How long have I been streaming? It is 1:04 in the morning. Wow, dropped frame 0. Good job. An hour and 47 minutes. I could probably do another 45 minutes. I want to at least start getting the layout. Probably do the schematic on this recording, the layout on the next. That'll plan a little better. Oh, did I click rectifiers? I meant Zener. Possibly. Well, Zener. Series, like, do any of these happen to, like, have USB in the name? Lol. That's okay. I bet as I start narrowing down on breakdown voltage and stuff like that, or I could take a look at this part, SMAJ, only seen that about 1,000 times, and look for other diodes in that family. That's probably what I'm going to do. Or see if this series, I'm looking in the wrong area. We'll start with that. Alright, I guess that TVS, Zener, active, in stock, EDA exclude, reverse standoff typical. The USB bus will have about 5 volts on it. So I'd want the breakdown to be a little bit of a margin above that. A reasonable amount at least. Oh, with breakdown min, that's like a-okay. So like even if I pick this part, right? Reverse standoff typical 5 volts, breakdown min 6.4. I shouldn't constrain myself that much, but that's not horrible. While that loads, I'm going to get some water. $14, hey, that's more than one. These are a lot beefier than what I'm looking for. Okay, I'll deal with that in a little bit. What time is it? It's 1:08. I think I'm going to call it quits for today. So this will be the schematic portion of this. I mean, the schematic's basically done. Next time we're going to finish picking parts and we'll do the routing. Hopefully that goes a little quicker than I think, and I can do that in a single live stream. The one after that will then be when we get the boards back. Well, I hope y'all, let's be real, this was very boring for most people. But for those who it wasn't, hope it was moderately entertaining. I'll probably post a link to this on my LinkedIn and business page, and yeah, have fun with switching converters. Alright, I'm gonna hit stop recording now. Stop streaming.